What is up, guys? Today we're going to build an acid resistant lining system for a secondary containment. We're going to model this system off of a existing project of mine that's currently in the final capital approval phase. And so this system has been designed to rebuild an existing concrete containment that's been severely degraded by sulfuric acid. And so our goal with this video is going to be three things. One, we're going to detail what goes into rebuilding and lining a concrete containment. The second thing we're going to cover is highlight some key areas of focus to increase the lifespan of the new lining. And lastly, the third thing, what we're going to do is show the material types that we selected for sulfuric acid service. Now, real quick, if you don't know me, at 22, I completed my degree in chemical engineering, and since I've spent nearly a decade studying, modifying, and implementing polymeric lining and composite technologies like epoxies and carbon fiber for the industrial sectors. I've been a part of and led projects from $500 to $500,000 in material alone, and I make these videos to help maintenance and engineering teams, with the goal being to help increase the understanding of and properly select coatings, linings, and composites for industrial processes. First, let's take a look at the task at hand. And from this photo, you can see where the sulfuric acid has attacked the original lining system and the underlying concrete. For a surface like this, once the acid has breached that protective lining, it will more rapidly degrade the entire system. And you might be asking, why is that? And the reason is the chemical makeup of concrete and its natural porosity allows the acid to move through that concrete and attack it with relative ease. For this reason, it's critical that we put a strong barrier between the concrete and the acid that's being poured into this containment. Taking a look at this render of the containment, we can see with more clarity where the acid has degraded most of the concrete and the portions that need to be rebuilt. So our first steps are going to be, hey, we need to prep the surface. And then what we're going to do is we're going to apply our primers all the way across the surface. And from there, you can see with this next step in the render, what we'll do is we'll mix and pour in an epoxy polymer concrete. And where I mentioned previously, standard concrete is susceptible to acid attack, and so polymer concretes use epoxy or other resin types as the binder. And this gives us the ability to rebuild concrete in aggressive areas with a step up in performance. And not only this, these polymer concretes are cross-compatible with the lining system itself, leading to a stronger bond and ultimately better performance. Additionally, the aggregate fill used can absorb more heat, and this will ultimately protect the to-be-installed liner from thermal shock failure. In essence, thermal shock failure is when there's water in the containment and acid is poured in, that reaction generates heat, which can degrade the lining system and the concrete there. And so this polymer concrete, again, will absorb that heat and disperse it or displace it so that we have less attack direct on the liner. Now, so far, we've prepared our surface and poured in our polymer concrete, but before we install the lining system, we need to address our floor-to-wall joints. And so even when these are properly lined, these joints are prone to liquids building up and staying in place. In the case of acid, this will mean continuous attack where that liquid is standing. Now, to combat this, we'll install a high build epoxy paste, and the reason for this is we're actually going to contour it in those corners, in those seams, in those joints to direct the liquids away from the joint. And so in this case, there's a drain in the center of the containment, and so we will contour this so that everything flows towards the center of that containment. And so this is something here, if you're looking at the render, you can see, hey, this is what a standard wall to floor joint looks like. And then you can see how we're going to cove that so that that material or that liquid, once it flows in, if it hits that wall, it will move down and then away from the joint. Now that all of our prep work is complete, let's install our acid-resistant lining system. And so due to the strength of the sulfuric acid, which in this particular application is 98%, we switch from a broad chemical compatibility general purpose epoxy to an acid resistant improved epoxy Novolac. And what we did was we stepped into the epoxy Novolac, which gives us improved chemical compatibility. And also we improved the hardener or the curing agent so that we can pick up even more performance from that system. So with that selection, our first coat of the lining we apply at 25 to 35 mils, and our target is really going to be a 30 mil average, but we give a range. And so just for clarity, 1 mil is 1/1000th of an inch. So when I say 25 to 35 mils, I mean 25 thousandths of an inch to 35 thousandths of an inch, again with our target average being 30 thousandths of an inch or 30 mils. Before that first coat sets, what we're going to do is we're going to broadcast sand into that resin. So while the resin's still tacky, we're going to broadcast sand into it. And this does two things. One, it will extend our overcoat window should we need it, but it's just good practice. Let's say we come back, hey, we missed the overcoat window. That sand that's in there will give us a good mechanical profile that we can bond to. And with that, it's going to increase adhesion. Now, the other side of this, so the second thing is going to be that sand is going to provide a degree of impact resistance and toughness to the lining because it's going to be something to help absorb energy. So the same way our polymer concrete absorbs heat, this is going to absorb energy and just make that coating last longer and protect it from things that may happen in the field. Somebody drops something on it, anything like that that could damage the lining. Once we've hit our overcoat window, we will then apply our second coat of the lining. And so with this coat, again, we'll aim for that 25 to 35 mil thickness with an average around 30 mils. And once that has all been applied, our installation's done. Now, lastly, it's going to be critically important to remember with an epoxy Novolac like the one selected, our cure to chemical immersion takes 120 hours. Now, to be clear, different materials can have different times. One might be 72 hours at 100 degrees. In this case, ours is 120 hours at 70 degrees. Whatever that number is, especially when dealing with strong chemicals, make sure we hit that cure to chemical immersion so that we get the best performance. If you're at 119 hours, are you good? Probably. I shouldn't say that, but just, between you and me, that 1 hour of difference isn't going to change anything. But if you say, hey, you know what, it's 48 hours, we're putting it back in service, that is going to cause a problem. And so this is the amount of time it takes to develop full strength chemical resistance. And once we have hit our 120 hours for this particular material, we can return this acid containment to service. So to recap what all we covered here, our goal with the video was one, to detail what goes into rebuilding and lining a concrete containment, which we did by covering the polymer concretes for increased strength and compatibility with the lining to be installed. The second thing we wanted to do was highlight key areas of focus to increase the lifespan of the new lining. And one of the big things that we can do is contour all of our floor and wall joints to minimize any standing acids and implement a sand broadcast to make the lining more durable and extend our overcoat window should we need it. And then lastly, I wanted to show you the materials we selected for this particular sulfuric acid service. And so again, we moved from a broad spectrum epoxy to an epoxy Novolac with an improved hardener, which drastically increases our resistance to strong acids like 98% sulfuric. Hope this was helpful, something you guys can use in your day-to-day operations. I just have one ask: if there's someone who could benefit from information like this, please share it with them. But otherwise, until we see each other again, stay safe and Godspeed.